continue working on this workshop examples, where we now considering the wind direction from theta equal to 0.19. So in the case of theta equal to 0.19, we have wind coming from here, theta equal to 0.19. So we need to calculate design wind distribution force for theta equal to 0. The pressure value is 0.71 C fixed. That is we obtain in the last one, where we have pressure equal to 0.17 C fixed. Now we need to calculate external pressure and suction for the two walls. So I'm drawing the diagram here for this case. Now in here we have I'm using the ruler here to demonstrate this one. We have a 16 meters that I'm drawing it here. We have 16 meters and we have 24 meters. So 24 meters here and 24 meters here. I'm just using the ruler to draw this up, and then we just connect this one. So that is 16 meters by 24 meters. That is given in the examples. We have wind coming from this side, so 16 meters drawn here, 24 meters drawing here. I'm just doing the plan view, 16 by 24. Now once we get that 16 by 24, this is the roof. So roof has this line, which is this line 8 meters. So that's I'm going to draw it here. So the roof has 8 meters, so that is the plan view for the roof, and we draw this one at 8 meters. So we have a two side of the roof that is shown here, two side of the roof. Now we can calculate the first of all, let's get first of all for a roof. We can put the pressure for the roof. Now for the pressure for the roof, we have a table 5.3a on page number 34, where we can calculate the roof, and we have H on D ratio is 0.5. That is calculated here. H is 5.5 and D is 24, so less than 0.5. Now wind is coming from this direction, so we need to respectively find the D and B value. Now once we have this horizontal distance from windward edge of the roof, so we need to get the horizontal distance from the windward edge. So 0 to 0.5, 0.5 to 1 to H, and so on, and H is 5.5. so we have a value of 2.75. if I take it here, so that is 0.5 H, and we have 5.5, so that is given 1 H. And then we have a 1 H to 2 H. 2 H is 11, so that is 2 H. And then we have a 3 H, so 3 H is 16.5. 3 H is 16.5 and get out. And so what I done, 0 to 0.5, 0.5 to 1 H to 2 H, 2 H to 3 H, and greater than 3 H. So that's what I place, and that H is 5.5. so if I substitute H equal to 5.5, I should get 2.75 meters, I should get 5.5 meters, I should get 11 meters, and I should get 16.5 meters, and then remaining is the 24, take away 16.5, because the whole length is 24. Now in this case we can put the values for the roof. For here, for the roof, let's draw the dotted line. So for this region, 0 to 0.5, 0 to 0.5, we have H on D ratio minus less than 0.5, so we have two value, which is minus 0.9, minus 0.4. Then we have a minus 0.9, 0.4 for the next region, so that is here. Next region, minus 0.9, minus 0.4, minus 0.9, so that is the value for roof. And for the next one, 1 H to 2 H, minus 0.5, 0. 1 H to 2 H, we have a minus 0.5, and 0, minus 0.5 and 0. And then we have next level, we have minus 0.30.1, minus 0.30.1, that is minus 0.301, and the last one minus 0.2, 0.2, minus 0.2, 0.2. So that is the CPE value for the roof. And now we can get for the side walls. So this is windward wall, this one leeward wall, and these are the side walls. Now for the side walls we can use table 5.2c, and we have a different value from 0 to 1h, 1h to 2h, 2h to 3h. So 0 to 1h is we already got here. So 0 to 1h is for the, let's say from here to here, 0 to 1h, 0 to 1h we have minus 0.65. so minus we are going to put this way 0.65, and then 1h to 2h minus 0.5, 1h to 2h, arrow coming out is a minus value 0.5. and then last one we have a 2h to 3h 0.3, 1h to 2h to 3h is a little bit bigger, 0.3, and the last section is greater than 3h, which is 0.2. 0.2 respectively. We can put it on this side as well, all these three values, because we have two side walls, which I'm not writing it. So exactly the same values that we're going to write it on these sides. So that is roof and side walls. So we don't need to work it out, this windward wall and leeward wall. Because if you want to work it out, that's quite easy. In this one here, table 5.2a, we can have a 0.7. So over here, positive value of 0.7, and the leeward walls we can use these tables here, work it out here, and we can get this value here. Now the important part is that we need to break it down, this one, into 6 meters of, I can use the red color pen. So because we have a 6 meter portal frame distance, so we have first one is a 6, so that is a 6 meters portal frame, that distance is q1. The portal frame has a 6 meters center to center distance, so distance between this portal frame is 6 meters. So that's what I'm drawing it here. So that is 6 meters here, and another 6 meters extended onto these levels. Now these portal frames are taking the two CPE value for the case of roof and side walls, because we have 5.5 meters and that is 6 meters. So we need to, let's say, 3 meters off from here. So we have this distance, because the portal frame generally going to resist the load in between these 3 meters on the east side. So we need to work it out, these pressures, this distance here. Now in here we can work it out how much pressures is subjected. So in here we are calculating how much kilonewton per meter. So we have 0.71 times 0.9, that is C fig, so that is 0.9. This 0.9 value is the Kc value, but I think we can correct it. This Kc value is 0.8, so we can substitute 0.8 and make the correction here. So that value is, let's say, 0.8 Kc value, 0.71. that is the pressure equation that we take. And this 0.65 times 2.5, so that is 0.65 coming from here, and we need to make this 2.5 and 3.5. so 2.5 can be obtained by taking, because this distance is 3 meters, so 5.5 is this distance, 5.5, because this distance is 5.5. so 5.5 take away 3, that will give us, because this distance is 3 meters, so 5.5 take away 3, that will give us this this distance between 3 meters, 5.5 meters. So that give us this distance 2.5 meters, and this distance give us 3.5 meters, which is 6 take away 2.5, that is give us 3 meters. So that we divided this one into zone, that is based on this value. So for the first one, 0.65 times 2.5, so we have 0.65 times this 0.65 times 2.5, and then we have a 3.5 times 3.5 times 0.5, this value. So that simplifications give this value. Now that is for the for this side walls. For the roof, we have 0.71 kc value is 1 for the roof. As you can see, kc value is 1 for the roof. And then we have a 0.9 times 2.5, so that's 0.9 for the roof is this 0.9 times 2.5 and 0.5 times 3.5. So we have 0.9 and 0.5, 2.5 and 3.5 distance, that is for roof. And then we get these values which are same, and in here the only difference is that we are multiplying this another number, minus 0.4 and 0 and minus 0.4 and 0. So we have this minus 0.4 and 0, that's for the second case. Now that is the external pressures due to the wind coming from that other directions. Thank you.